Ayubawan students, and a very warm welcome to Study Hub Sri Lanka. Have you ever really thought about why you lurch forward in a bus when it suddenly stops? Or how a massive rocket can launch into space? Well, the answer to all of that lies in three simple but incredibly powerful rules discovered by Sir Isaac Newton. Today, we are going to break down his famous laws of motion. Let's get started.
So here's what we've got planned. We're going to start with the absolute basics. What even is a force? Then we'll walk through Newton's three laws one by one. And to finish up, we'll see how these laws connect to other really important ideas like momentum and weight. By the end of this, you'll see how it all fits together beautifully. All right, let's jump right into our first big question. What exactly is a force? Well, to put it simply, a force is just a push or a pull. That's it. Every single day, you're using forces. When you lift your school bag, when you push a door open, or kick a football. It's the reason anything moves or stops moving, for that matter. Okay, now think about this for a second. You could probably push a table across the classroom pretty easily, couldn't you? But what happens if you try to push a big bus all by yourself? It's not going to move an inch. So why is that? The reason is all about the other forces that are pushing back against you. You see, for anything to start moving, the force you apply has to be bigger, stronger than any forces that are pushing back. That resisting force is usually something we call friction. So when your push is stronger than the friction, you create what we call an unbalanced force, and that is what makes the object move. With the bus, the friction is just way too big for one person to overcome.
So here's a really crucial point to remember. Force isn't just about how hard you push. The direction you push in matters just as much. Imagine a cart is already rolling along. If you push it from behind, in the same direction, it speeds up, right? But if you push from the front, against its motion, it slows down. This is why we say force is a vector. It has both a magnitude, which is just its size or strength, and a very specific direction.
Okay, now that we have a good grip on what a force is, let's dive into Newton's first law. I like to call this one the law of laziness. Why? Because it's all about how objects just want to keep on doing whatever they're already doing. Now, the official definition might sound a little bit complicated, but the idea behind it is actually very simple. Things that are still want to stay still, and things that are moving want to keep moving at the same speed and in the same direction. Basically, nothing changes unless some outside, unbalanced force comes along and messes things up. And I can guarantee you every single one of you has experienced this law. Just picture it. You're standing in a bus. When the driver suddenly hits the brakes, what happens? You lurch forward, no? That's because your feet stop with the floor of the bus, but your upper body wants to keep moving forward. And on the flip side, if the bus suddenly starts moving, you feel like you're thrown backward because your body wanted to stay right where it was, at rest. This resistance that objects have to changing their motion has a special name. We call it inertia. And that is exactly why wearing a seatbelt is so important. When a car stops suddenly in an accident, your body's inertia wants to keep flying forward. The seatbelt provides that crucial unbalanced force that stops you safely along with the car. Let's move on to the second law, and you'll see how this builds on the first one. This is where Sir Isaac Newton gave us the actual math to describe exactly how forces change motion. And it's one of the most famous and important equations in all of science. So, what the law says is that an object's acceleration, that's how quickly its speed changes, depends on two main things. First, it's directly proportional to the force. That just means if you push harder, it accelerates faster. Simple enough. But it's inversely proportional to its mass. This means for the very same push, a heavier object is going to accelerate a lot less than a lighter one. And all of that smart-sounding stuff is summarized in this beautiful, simple formula. Force equals mass times acceleration, or F equals m. The force here is measured in a special unit named after the great man himself, the Newton. And we just write that with a capital N. So let's actually use this formula with that first example on our table. Let's say we want to find the force needed for a 5-kilogram object to accelerate at 2 meters per second squared. All we have to do is multiply them. So F equals 5 kilograms times 2 meters per second squared, which gives us 10 newtons. See? Simple, isn't it?
All right, we're on to our final law, the third one. And this one has a very simple but really profound message. You can't touch something without it touching you back. It's all about pairs of forces.
The law is famously stated just like this. For every action, there is an equal and opposite reaction. What this means is that forces always come in pairs. If you push on a wall, guess what? The wall is pushing back on you with the exact same force. You might not see the wall move because it's so massive, but you can definitely feel that force on your hand. A perfect, simple example is when you let go of a balloon you've just blown up. The action is the balloon squeezing the air and pushing it out and downwards. The reaction is that escaping air pushing the balloon up. The balloon shoots up into the sky because of the force of the air leaving it. Action and reaction. It's a pair. And once you start looking, you see this absolutely everywhere. When you swim, you push the water backward with your hands. That's the action. And what happens? The water pushes you forward. That's the reaction. It's the exact same idea when someone rows a boat. We are always using these action-reaction pairs to move around. Okay, we're in our final section now. Let's use these 3 incredible laws to help us understand 2 other very important ideas in physics. One is momentum, and the other is the big difference between mass and weight. So, what is momentum? Well, you can think of it as a measure of an object's quantity of motion, or how hard it is to stop something that's already moving. It depends on 2 things, the mass of the object and how fast it's going in a particular direction. That's what we call velocity. So a heavy truck moving very fast has a huge amount of momentum, while a pen rolling slowly across your desk has very little. Now, students, this is a very important difference to understand. Mass is the amount of stuff or matter inside an object. It's measured in kilograms, and your mass is always the same. It doesn't matter where you are in the universe. Weight, on the other hand, is a force. It is the force of gravity pulling on your mass, and we actually calculate it using Newton's second law. Weight equals mass times the acceleration due to gravity, or W equals mg. So your mass is the same on Earth as it is on the moon, but you would weigh much less on the moon because the gravity there is much weaker. So, let's do a quick summary of the 3 big ideas from today. The first law is all about inertia, objects resisting change. The second law is the famous formula, F equals ma. And the third law tells us all about action-reaction pairs. These 3 laws are truly the foundation of how we understand motion. Okay, I'm gonna leave you with one final thought to puzzle over. We know that the Earth pulls you down with the force of your weight. Now, according to Newton's third law, there has to be an equal and opposite reaction. So, my question to you is, what is that equal and opposite reaction force? Have a think about that. Thank you so much for joining our lesson today at Study Hub Sri Lanka. We will meet again with another episode from your science subject. Until then, keep learning.